Now this is just a very quick run through of basic physics that are involved here. Force equals mass times acceleration. You need to impart force onto the body in order to make a change. The mass is the deforming component of the force, the actual weight, if you will, of the body of the doctor being applied to the body of the patient. The acceleration is how quickly that force is applied. In high velocity, low amplitude manipulation, acceleration is everything because the deforming mass imparted to the patient can damage soft tissues such as ligaments and organs. By applying the force to a very specific depth at a very high velocity, you can accomplish your goal without the risk of damaging soft tissues that are not your target for the manipulation. Now, the Dynadjust spinal manipulation training system is a very sophisticated electronic system to be acted upon. When you apply pressure to the top of the device, the sliding cylindrical design allows the top half to slide into the bottom half where there is an actuator rod which comes up through the electronics, through the photointerrupters and the optic sensors, and it records the depth and speed of the thrust, and at the same time it records any changes in the angle of the thrust, any wobble in any direction, including wobble or rotational distortion around the longitudinal axis. The system includes a spring in the bottom half, which is changeable depending on the type of situation that you're training for. The spring can be very, very light, or it can be very, very heavy. For instance, in cervical manipulation, you might use the yellow spring to simulate working on a person's neck where you'd need a lighter mass. Now the mass, of course, because of the spring, is a constant. You can only apply so much mass to the system, and if it doesn't bottom out, the mass becomes a constant. So the variable becomes the acceleration. If you increase either the mass or the acceleration, you automatically increase the force. And our goal, most of the time, in high velocity, low amplitude manipulation, in order to increase the force, we increase the acceleration, not the deforming mass. Now, the electronic Dynadjust device is the very first system for training that allows a person to train for every aspect of spinal manipulation. It provides not only isometric exercise, but dynamic exercise that is very specifically targeted to the exact muscle groups and the parts of the central nervous system necessary for producing high velocity, low amplitude manipulations. So why HVLA? If you apply a force to the middle of a system of bones and ligaments and joints with viscera underneath, if you apply a slow, steady application of the force, you end up with deformation of the system along a much broader plane. In other words, this is more of a mobilization than an actual manipulation. When you apply a high velocity, low amplitude thrust to a specific part of the anatomy, you achieve what has been referred to in the past as cleavage. In other words, it's been clearly demonstrated by research done by the top biomechanists that a high velocity, low amplitude thrust will not produce a gradient or a change in the entire system, but rather it will produce a very specific action upon the joints and the tissues that are targeted for the thrust, such as mobilizing a fixation lesion in a very specific motor segment. For instance, if this was a segment of thoracic vertebra, one might want to impart not only P to A thrusting into the segment that you're looking to affect, but you may also want to impart a little bit of torsion in order to cavitate more than just the front and back joints. You might want to cavitate all four joints, or in the case of thoracic segments that actually have ribs attached, you may want to affect the entire motion segment or motor segment with your thrust. And of course, the Dynadjust device is programmed to record and report distortion in the longitudinal axis. So when you apply a thrust straight down with a little bit of torsion, the device will report that. And of course, you can practice doing that without actually working on a human being. The Dynadjust device measures and reports lateral changes in the direction in percentage from neutral. So if you produce a thrust, your intention is to produce a thrust straight down. If you deviate in any direction, forwards, backwards, or side to side, it reports that in percentages of deviation from neutral. And along the longitudinal axis, the unit reports the deviation from a perfectly neutral thrust in degrees of change from neutral. And the total force of each adjustment is reported in newtons.